Welcome to tonight's debate. I am Michael Pope, the founder of Testing Doesn't Matter. And here to give a counter argument is Paul Biggar of Continuous Integration. I'd be like, testing doesn't matter. He's like, what the hell are you talking about? It's sweet. Actually, I run a little recruiting business called Captain Recruiter. I do tech recruiting for startups, and that's all you need to know about me. The star, or the first half of the star lineup tonight is Paul. He's the founder of Circle Continuous Integration, or perhaps better known as Circle CI, and he will be happy to tell you all sorts of interesting stuff that customers are doing on his platform and that they've learned, and I'm going to shut up now and let him talk.
All right, folks. So thanks very much for the introduction. What I'm going to do today is I'm going to talk a little less about CI itself, because I think everyone knows how to push code and get an email that says whether it worked or not. And what I'm going to talk about is kind of the war stories that we see from running CI at scale, both from our customers and from people who are doing CI at much greater scale than we are. And also, of course, from people who did CI in years past when things were slightly different. So my background is I'm the founder of Circle CI, one of the founders of Circle CI. We make continuous integration as a service principally for Rails. Most of our customers are Rails, but every one of our customers is web apps. So we focus very much on having an awesome CI experience for all of our customers, and for anyone who's doing anything around developers writing code for web apps. And so the first story that I want to tell you tonight is about a friend of mine, a guy by the name of John Taylor. And about 2 years ago, he was working for a startup here in the city. It was a 10 to 12 person startup, and back then when you wanted to do CI, you hired a build guy, and he was a build guy. And so he came on board at this startup, and the CTO had decided that they need continuous integration because it's a best practice, and goddammit, you got to have the best practices if you're in a serious funded startup. And so he was brought in, and he had done this many times before, and so he set about with his standard sort of MO. He got a Mac Mini because that is the machine that people use to run their CI. In the past, at least, what you do with a Mac Mini is you can install all of your desktop operating systems on it, and so that was the standard MO that people have had for years now. And he spent 2 days setting up Jenkins. I'm sure no one needs an introduction to Jenkins, the standard open source CI server. And so he spent 2 days on it, and he installed installed Postgres, installed all the libraries you need, the standard whole shebang, made it work. And set it up with the train leaving the station model for CI. That's the model where you run tests, and then when the tests finish, you do another git pull and you run the tests again. So you don't test every push; you just test whatever's there when you're done. And this was all going well. He had master tested, and it was 18 minutes or something like that. And then the developers started complaining. They were saying that they were getting the blame for the builds that had happened, or the pushes that had happened before their pushes that broke, but that blamed them. So what was happening was that the train was leaving the station and got 3 pushes with it this time. One from person A, one from person B. Person B was being blamed for person A, for person A's bug. And so what I'm going to be doing for the talk, by the way, is because it's war stories and there's kind of nothing put up. I'm going to flash the lessons that we kind of have to learn from this. Please feel free to ignore this. I kind of need something to put on the slides. So what they started doing was test every push. They initially wanted to test every commit because this is what people used to do in the bad old days. But people use Git, and it's not really possible to test all the little pushes that people do, or little commits that people do. So test every push what was the rule. And what happened when they set this up is that developer productivity dropped. Now, continuous integration isn't something you really do for the sake of testing or for the sake of continuous integration. You're doing it to get your developers to be more productive. There's research and studies that show that continuous integration makes you 90% more productive. But if you're not achieving that, then what the hell were you doing? And those guys were not achieving it. In fact, they lost a lot of productivity. And the reason this happened is that their 18-minute build was no longer taking 18 minutes because people were pushing faster than the test could run. So instead, developers, instead of waiting 18 minutes, they were waiting 28 minutes and 38 minutes. And as the day got longer, it got worse. And when it came to 4 p.m., and little known fact, everybody pushes code at 4 p.m. The graphs that show our monitoring show basically a spike around 4 p.m. because everyone wants to leave and go home. But they couldn't leave and go home because they were getting way too many pushes. And they had to wait because if master wasn't green, then they were going to be in a whole lot of trouble. So what started happening is that the builds started taking a long time. And developers waiting for their builds would check their email. They'd have a coffee. They'd start to read Hacker News or whatever was popular 2 years ago. And kind of everything, productivity went to shit. Bugs weren't being done. Product managers started getting annoyed. And of course, even though John had just implemented the test every push that he was told, he was the one who got the blame. So the lesson here is bad CI is actually worse than no CI. If you set up Jenkins and you make your team work with it, you better make sure it's fast as hell. Because if it's not fast as hell, you're going to damage your team's productivity, and they're going to have been better off if you didn't set this up in the first place. Slow tests generally lead to low productivity. And so John went and he fixed this. He got rid of his slow little Mac Mini, and he got the biggest, beefiest box that he could find. It was 2 CPUs Xeon with 8 cores and 16 hyperthreads and 64 gigs of RAM and an SSD. And SSDs are the bomb for testing. Every test that you will run as a web developer typically hits the database. And the database hits the file system. And the file system is the slowest part of any testing. I/O in testing and in CI, I/O is almost always the bottleneck. And SSDs are absolutely essential. This was 2 years ago. SSDs were expensive, didn't matter, got the job done. But they had bought this massive machine. What they wanted to do is run more than one test at the same time. They wanted to run their tests in parallel. And it's not that difficult to run the tests in parallel, right? There's parallel tests is the gem that allows you to do this. But what happens when you start to run your tests in parallel is that they interfere with each other. You run 2 tests at the same time, they both want the database, and one will clear it while the other one is running. So you need to start to manage multiple databases and bring multiple databases up at the same time. Heaven forbid if they also touch at a file system level, and you end up doing what John's company did, which is they start rewriting their app. And so after about 6 weeks of developers working on this and making their app making no tests interfere with other tests and spinning up multiple databases at the same time, they finally got it down to 8 minutes. And 8 minutes is all well and good, everybody's happy, until the developers start getting a little restless again, because they want to test all branches. If you don't test all branches, then what you do is when you merge your code into master, then that's the first time that you'll have got CI exposure on that code. And CI, as I'm sure everybody has discovered, doesn't necessarily run identically on your CI server as it does on your local machine. So John, again, it's his fault, even though the developers wanted this. Productivity is down again because they've started testing all branches. And so it's time to start looking to EC2. EC2, as you're probably aware, has terrible I/O. And so John was in the process of fixing all this and working out how to make EC2 decent as a platform for running tests on, when he got a little bit lucky. So what happened was, this was just before Christmas. And he went away for Christmas, and everyone else went away for Christmas, and tests started going down, so there wasn't that much traffic, there wasn't that much problem. They moved offices over Christmas, and in the new offices, when everyone came back, the problems had gone away. Nobody was really experiencing these problems. No one was complaining to him. The productivity was back up. The team was happy. The devs were happy. The product managers were happy, and so he was happy. And so he moved on. He started working on some other stuff. About a month or two later, one of the developers approached him and said, whatever happened to that CI server that you had set up? And what had happened is, when they moved office, someone lost the server. And productivity went back up, because a bad CI is worse than no CI. And so they'd gotten, they'd spent all this time, all this money on the server and his salary, and in the end, they actually got screwed by it. So John had a bit of a nervous breakdown and moved to another company. And that company came and worked with us at CircleCI. And we, what I want to talk about, after that terrible war story, is a little bit of where they would have gone from there. They're starting to move into the cloud. We've established that EC2 has pretty bad I/O. And how are you going to fix this sort of thing? And talk about this because we've gone through this process. But any one of you who wants to set up an internal CI, people who don't like the cloud or want to run it on your own machines or on your private cloud or that kind of thing. I think there's a lot of lessons here into how to make tests run fast and run fast enough that your team is productive. So the first rule of CI is that your tests run from end to end. You want to make sure that you do everything. You check out the code. You load the schemas from scratch. You don't want any remnants of previous tests causing problems with your new test, or worse, causing the new test runs to pass, even though they should have failed and nobody noticed because of some remnants of a previous test. And so, because this, it can be very slow to run this clean slate from start to finish. In particular, we've noticed a lot that doing a bundle install from scratch is a 6-minute task on anyone's code base which is at any size at all. Same thing with checking out code from GitHub. A fresh, clean install can often be hundreds of megabytes large, and if you're a long way away from rack space, then that's going to be a problem. Even when we're running EC2 in the cloud, we have very good I/O, we have very good download speeds from all these from Ruby gems and from GitHub, and even then it's still all not that fast. So what we do is we cache aggressively. Anything that comes out of Bundler, or anything that comes out of Ruby gems, anything that comes out of GitHub is cached. Because the one thing that you have on EC2 is you've incredibly fast throughput to S3. You can get 200 megs a second to S3 if it's in the same availability zone. And so we take these files, the things that are going to be the same every time, we zip them up and we send them to S3. And you can do exactly the same thing, and that will turn the 10 minutes of download that you get at the start of every clean build to you make it a slightly dirtier build, but it starts in 10 seconds. And I say, but watch out. The reason is anytime you change your Ruby gem version, you need to, or your Ruby patch set, you need to blow that stuff away, or else you're going to be in trouble. So the second thing that you can do to make your CI fast is to realize that CI data is ephemeral. You don't give a shit about the code or about the what's in the database or what's left on the file system at all. It's all going to be blown away 5 minutes after you run your test. And so once you do that, you start to realize that there's a whole lot of changes in how you set things up, because databases are set up to keep your data. You run your tests with databases, but you don't care about keeping your data. You're going to get rid of it anyway. And so there's a Heroku, or there's a presentation called Grease Your Suite that describes how to do this. But a couple of things that kind of turn off journaling on your file system, turn off write behind cache on your databases, turn your caches up to the max on the file system, because any time that you touch disk, you're going to be in serious trouble. And the third and the biggest thing that you can do is run multiple tests suites at the same time on the same hardware. So you buy those big ass boxes that that John was using, and you need to you're trying to make your test parallelized as much as possible. The best way to do this is to run lightweight virtualization. So virtualization is there's a thing called LXC, which is Linux containers, and what you do is you take your big box and you split it into multiple containers, each with their own file system and each with their own databases, and they're sandboxed. They can't talk to each other at all. And that means that you can run whatever the hell you like. People push 8 times in a row, run it on 8 containers in a row. And you can run them all at the same time. You don't need to keep this stuff queued, and it scales as your as your load gets up, you buy another machine, put another 8 to 16 containers on it. So this is the same technology that Heroku uses. And Heroku puts, I guess, about 400 of their dynos on these machines, but they have a different use case. They're trying to keep their virtual machines up as much as possible because they want to keep your web servers up as much as possible. But if you're doing CI, you just want to take that test, throw as many resources as you can as possible, and just blow through it as quickly as possible. And so we run typically 8, but as many as 12, depending on your configuration, LXC containers at the same time on a particular machine, and just throw resources at it in order to get your tests out the door and that notification into your inbox. So the one of the most sort of pervasive problems that you get when you're running CI, and this is the part of the talk which is about our customers and the kind of problems that they experience. And the biggest problem that you get is intermittent failures. Failures that it works sometimes, it doesn't work another time. You press the retry button and all of a sudden it works, and so you can go home, and then your colleague spends half their day tomorrow wondering why their tests don't work because they're sure it was working yesterday. The goal of CI in an organization is obviously productivity. But people think of it as that the goal is to find any bugs. But you're not really interested when you push in finding if there's any bugs in your application. What you're interested in is, are there any bugs in your push? Is there a difference between how reliable your application is before your push versus after your push? And that's the thing that you're trying to do. So anytime that you have anything random or different between one push and another, you're going to suffer from these intermittent failures. And there's a couple of them that we see, and I'm going to go through kind of strategies to deal with them. The first is time zone problems. Daylight savings time is the day when our support load triples, because you all use time zones, you all use time in your applications, and all of a sudden it's daylight savings, and the tests are failing, and it says something about time zones, or that the thing is an hour off, and no one seems to put 2 and 2 together to realize that time zones are a bit of a problem. But because it only happens twice a year, ignore time zone bugs. They press retry the next day and just kind of move along. A much bigger problem is versions for Ruby and gems. The difference between one Ruby patch set and another Ruby patch set is significant. There was one put out last week which had seg faults all over the place, and immediately caused a whole load of our customers to have problems because they didn't specify very accurately what version of Ruby they were using. If you use Heroku, there's a place in your gem file that you say whether you want to use Ruby 1.9.2 or 1.9.3, but it doesn't specify what version or what patch set of 1.9.2 and 1.9.3 that you're using. And there is a little bit of a syntax to fix that. RVM has this incredibly ugly hack that allows you to specify the exact patch set. But if you and your team are not using the same patch set, if you're not using the same patch set in production as on your local machine or your CI server, you are going to find different problems at various points. And one of the most pervasive, of course, is when a new version comes out and something somewhere automatically updates and you haven't, and you're not going to be able to replicate that local bug or that bug on your local machine. And file ordering bugs are bugs where I would say every single one of you has suffered from this bug. I'd say every single one of you has not known the root cause of the bug and has just kind of patched it and moved along. File ordering bugs happen when you have a Mac machine and you write your code on a Mac and you deploy your code to Linux, which is what I would wager everybody in this room does. And the difference between the two is that the Mac file system, HFS+, orders directories alphabetically. And the alphabetical isn't so important as what's important is consistency. You get the same version every single time you run your tests. And so you never experience a different application load ordering. Whenever you push this to a Linux machine, whether in production or in test, they will load the contents of a directory in a different order. So this manifests for specs. Everything that's in your spec directory is loaded in whatever in whatever order the file system gives it. And on Linux, it's going to give you some arbitrary order and a different arbitrary order every single time. And on Mac, it's going to give you the same order every time. And that means that your application loads in a different order Your monkey patches load in a different order. Your classes are opened and closed in a different order. All of the contents of your controllers directory and all that sort of thing, all loaded in different orders. And so this is easily the biggest problem that you will face with random errors, and why does my CI server fail? A slightly less important problem: people like to order their tests randomly so that they find those bugs. But that's not what your CI is for. If you run tests in a random order, then what you're going to do is you're going to get different interactions between the different tests, and they're going to experience, every push is going to have different interactions. And that means that when you push and it works, and you push later and it doesn't work, you're not going to know for sure that the difference between the two pushes was your code. It could have been just this random directory, or this random file ordering that RSpec allows you to do. So by all means, set it to random, but set it using a seed on your CI server. And that means you'll get a consistent test ordering. You won't get a consistent file ordering, unfortunately, but that will get you through a lot of the problems that you experience. So final part of my talk, and then we're going to go to questions, and I think we're doing pretty well on time, is talking a little bit about the future of continuous deployment. A lot of people, I would say, in this room are starting to look at doing continuous deployments. It's becoming a little bit of a best practice. GitHub does it, Heroku does it, Facebook does it, Etsy does it, everybody does it. But there's a lot of people who, the people in small companies who are doing it are doing it at a very small scale. And the people who are doing it at Facebook and Etsy and IMVU are doing this incredibly advanced continuous deployments that really won't get to the rest of us for another 2 or 3 years. And so this is kind of a preview of where continuous deployment will be in 2 to 3 years' time. So IMVU is a startup that's kind of like Second Life, and it's been around for a couple of years, since about 2004, 2005. And they pioneered everything that we know today about continuous deployments and continuous delivery. If you've heard about the lean startup movement, it's done by their founder, Eric Ries, who's well known in startups and Lean Startup Handbook, or the Lean Startup. And at IMVU, they came across this problem while they were doing continuous deployment, and it's the white-on-white problem. They deployed code and then noticed that immediately their metrics started failing. They started making a lot less money right after their deployment. And they had a lovely continuous deployment infrastructure until that point, probably the most advanced in the world. And that had allowed them to deploy a white buy button on a white background. And obviously, they stopped making any money when that happens because nobody is able to click the buy button. And so what they started doing is they started tying their metrics to their continuous deployment so that they could automatically roll back anytime key metrics like customer happiness, engagement, traction, anything like that would cause their deployment to roll back to a good, to the last good known version. And this was about 5 or 6 years ago, I think, that they started doing this. And since then, it's been improved upon, and Facebook does an awful lot of this with feature flags. Feature flags are where instead of replacing the old code with the new code for whatever feature you work on, you put it inside an if statement. If feature flag, do new code, otherwise do old code. This allows you to deploy new code without actually immediately putting it in front of customers. So you can tweak the feature flag to allow it to be shown to a small number of customers at a time. Facebook does it to show you something like, it's very powerful and allows you to show this new code to 1% of women between the ages of 18 and 36 in California. And you start by showing it to tens of people, and then all of Facebook, and then tens of thousands, and eventually up to everyone's using it. And then you go back and you delete the old code and you deploy that. So that is the feature that is nearest to coming to normal people. And there's already libraries in Ruby and in Node that allow you to do this sort of thing. And the final thing that I'm going to talk about is everybody knows that you want to keep master green. But GitHub have a deployment policy which kind of goes to extraordinary lengths to keep master green. And what they do is they force you to push code. They don't allow you merge any code to master that hasn't already been in front of a user. So they deploy from branches straight to their users. And once that's done and it's verified that the bad things and the metrics aren't going down and the bad things aren't happening, only then can they merge it to master. So they're prioritizing their ability to ship master and to keep master green by doing this. And it's the same as if they had done it the other way, except more reliable, because they still show uncompleted features to a small number of users. But no matter what, master is known, reliable, absolutely must work. So that's the end of all of my war stories. There's a couple of links here that you might be interested in. The common problems is discussed in the first link, and the making your test suite faster is discussed in the second link. And of course, if you're looking for a good continuous integration service for your Ruby apps and for your web apps in general, I'd encourage you to go to circleci.com and check that stuff out. And thanks everyone for coming. Okay. All right. Any questions?
The practice you just described at the end there, I haven't heard about that before. So does that mean that there's a queue of changes that are being tested one at a time against users, something like that?
So
because I'm trying to imagine what master means when you do that.
Sure.
I guess you're never deploying master because everybody's always doing work.
So the question is, do you still really have master if you do that, and how does GitHub actually implement deploying from all these branches? And I don't think that they went into it in the blog post where they discussed it. My understanding from looking at how Mozilla did this, where I used to work, is that they basically send the results of different branches to different people. Same as doing A/B testing, you send them to a different endpoint, or let them download a different set of assets. Yes. So yeah, I mean Mozilla, it's different clients, but if you can A/B test something, then you can do the same sort of thing off different branches as well. So I'm going to presume that that's how that works, but I don't know for sure. Anyone else? Yeah, the question is, does common problems discuss file ordering? That's the major thing that it discusses. It's the problem that everybody experiences, major problem where people are just throw their hands in the air and click the report bug button. So that's the thing that we go into the most detail about. Okay, great. Thanks, everyone.
Hey, everybody. I'm Matthew Kocher. I'm a software developer here at Pivotal Labs. I've been here for about 3 years and dealt with a lot of our CI problems. So I just wanted to give you guys an overview of how we've dealt with CI over the time that I've been here, and where we are now, and some of the problems we encounter and solutions, or maybe not solutions, but techniques that I advise people to use when they're getting started and when they have a long test suite that they're starting to hate. And so I think we'll find that a lot of the content overlaps with what we just heard, so I'll try and skip over some of that. I do want to say that I knew about the file ordering problem because I discovered it during a push to production, not in CI. So there are worse times to figure about it than when your CI build is failing. I don't know how many of you know about Pivotal Labs, but one of the things we are known for is testing all the time. We are big believers in test-driven development. Every project here has a CI build. Every code change we make has tests around it, and it's not just something we pay lip service to. It really is something we do. This means that if we are deploying some odd service, if we're deploying React Memcache, Redis, MongoDB, not that I'd advise you to, we will write tests that actually test that given component. So it doesn't matter what it is. We want to be able to run tests against it and see that it actually does what we think it's doing. This means that we have a lot of sort of custom CI. We often have custom CI runtimes that we need to make whatever that project build work. I want to start out with sort of a history of how we've tackled these challenges. Sort of the first version of CI here at Pivotal, I don't know exactly when it started, probably more than 5 years ago, was one shared beefy machine. I think this will sort of parallel a lot of the stuff we already heard, which was one shared machine for every project in the office. So we're a consultancy. Now we work on probably 40 projects at a time in the office, in this office here. At the time we were smaller, but we had 10 entirely different code bases running on one machine, which is okay. It's great for utilization because they're keeping that machine busy all the time, but it means that anytime one machine needs a different version of Postgres, a different version of MySQL, or if one machine wedges this, or if one build wedges the CI daemon for a while, you're all sort of stuck there, and you have this, what I refer to as the tragedy of the commons, where nobody wants to go fix the build box because it could be anybody, and it's probably not them, so it's probably not worth their time to go look at it, and somebody else will go fix it soon. So what we ended up moving to at that point was not that, sorry, version 2, which was a Mac mini farm. We had a tower of Mac minis in the back room that would have been about this tall if we'd put them all one on top of each other. We spread them out for earthquake purposes. But every project that came in would be issued a CI box. Developers would then set up the CI for their project, and that box would live with the project until the end of time, or until that project outgrew the one CI box that they had. This actually worked pretty well. It was a nice distributed system in that every team was responsible for their own build. If their build was wedged, they knew whose build was wedged because it was their build. If they needed to upgrade something, they could know which box to go into and upgrade. So it was a fairly good system, but the problem for us is we're a consultancy, and so at the end of 3, 6, 9 months, people would be heading towards the door. They'd be, spooling up their own team to work on this, and we'd sort of come out with this used Mac Mini and go, would you like to buy a used Mac Mini? And for tax reasons, we have to sell it to you at list price. And so nobody actually wanted used Mac Minis at list price, it turned out. They all would go to the Apple Store. And so we ended up with all of these older Mac Minis that we didn't really want to sell, we didn't really have anything to do with, and it was sort of this ugly end of an engagement thing. We really want as we're going through on a project, what we want to do is sort of silently roll off the project. So you may start a project here with 4 Pivotal developers, 0 client developers. By the end of the project, soon after, you'll go down to 3 Pivotal developers and you'll hire somebody. Eventually, you'll get down to 1 Pivotal developer and 3 of your own developers. And then one day, that last person just sort of disappears and you keep going with all the knowledge you've learned while you've been at Pivotal. This sort of Mac Mini was sort of gave us a symbol of the end of the engagement, where there was this chance that a team that we'd finally taught to write, or that we'd taught to write tests, that we'd encouraged to write tests, would now have this barrier to continuing having CI as a thing they had available. We really wanted it to be a seamless transition. So the answer to this is the answer to any question these days, is taking it to the cloud. As I started here, this was sort of a goal that people had in mind, but nobody had any idea. I stuck around I worked for about a year, and then it kept coming up as something we all wanted to do, and I said, okay, give me 2 weeks and we'll get something worked out. And what we came up with was what we call Lobot. For those of you not familiar with Lobot, Lobot was the chief administrator in Cloud City and Star Wars. It's a non-speaking part, but he's quite powerful, quite silent, powerful in his silence. And we thought he represented what you needed to maintain your CI sanity in the cloud. So the goal was to get a project CI set up in an hour. We have 40 projects at a given time. We start a new project most weeks. Some weeks we start 3 or 4. Having someone whose job it was to set these instances up, to set up builds in Jenkins, to learn how to install Ruby properly, to learn how to write a good CI build for a Ruby project. All of that takes time to learn to do it right. If any of you have set up CI by hand, you you've put this time in, you've solved these problems, and you solve them over a period of days and weeks as they become apparent. You find that if you start a daemon every time you run a build, eventually you have 50 copies of that daemon running. All of that kind of stuff you learn gradually, and it takes a while to do. So we really wanted to get it down to about an hour to have a reasonable CI build going. The question then is, well, what's everything? Lobot actually gives us a way of interacting with EC2 so that our developers on the floor don't have to know the intricacies of EC2. They have to know how EC2 works. Everybody these days, as a developer in a Rails shop, sort of has an idea of what EC2 is. They know how it works. They don't necessarily know how to upload their SSH key to EC2 and start the instance with that SSH key. They don't know how security groups work. They don't understand that it's just a firewall. They may not understand how to configure a firewall anyways. So asking them to learn how to do that while they're learning how to set up CI isn't particularly useful. And the sort of the easiest one on this list is actually launching an AWS instance. But we wanted to make this easy. We also wanted to provide a bootstrap script for the CI server. So actually get your server ready to go. So install all the dependencies that you need to install Ruby, and then install RVM. The bootstrap script gets out of the way pretty quickly and gives way to running Chef on the box. So we use Chef Solo for this. I'm a big fan of Chef Solo for small systems. There's a little bit of a learning curve if you're coming to it from Ruby. From pure Ruby, it's its own DSL. It's a little special, but it's really nice for configuring a box or two in an automated manner. We initially wrote Chef recipes for installing all of the things that we sort of thought we needed for a generic Rails application. So this was all the things you see on this slide. I won't read them all out, but sort of the interesting one for us was, or the special one really, is Nginx with a basic auth and SSL. When you're actually putting CI boxes on a public cloud with public access to it, if you have access to the unconfigured Jenkins UI, you have access to all of the source code for that company. So and basic auth without SSL is quite fire sheepable. Is that still a word? I may be dating myself. It's sniffable. So we configure Nginx with SSL from the outset so that builds are secure in EC2. So you have 443 and 22 basically open to the world, and the rest is fairly secure. And we sort of install the basics that people expect, or people come to actually expect from a CI box. We install Qt so they can install Capybara WebGit. We make sure that XVFB is installed so that they can actually run web browser tests on a headless instance. And we attempt to monkey patch CI reporter into the Rails app so that you actually get pretty output from Jenkins about what tests failed, which tests passed. CI reporter, if you haven't looked at it and you're running a Rails build in Jenkins, it's a really nice way to actually be able to see how many tests failed in a given build, which ones were failing, which ones have been failing over time, and it's a really quick win if it works for you. There are occasions when it just sort of blows up in your Rails project and you wish the maintainer would do something, or you think, gosh, I should go fix that. And at that point, I usually just take it out of the build and resign myself to reading build logs. But it's really nice when it is working. So we did that, and what we found was that it was a lot of work to actually maintain those chef recipes that configured all of the CI box. And we looked around the internet and found that Travis CI, another hosted CI provider, actually publishes all of their chef recipes for how they configure a worker box. So what they have, if you're not familiar with Travis CI, they have free CI for open source projects, and they actually, very similar to what was described with Circle CI, they spin up an instance for every build, and they run your build in that. The nice thing, what we ended up doing with Lobot, and we're about to release this, is we've torn out all of our chef recipes for configuring a build, and we've pulled in the Travis CI recipes so that when you go to spin up a CI box, you end up with an Ubuntu 12.4 instance that looks exactly like a Travis CI worker box. So if you want to know how to get Capybara WebKit tests running on your box, you can go look and see how do people get Capybara WebKit running on Travis. Most people, those discussions are usually out in the open, and it makes it a nice place to actually go and look for how do I do this in CI, because it's not just how did somebody configure their random box, but how do they do it in Travis. And if you can look in public projects Travis YAML files and see exactly how their builds are configured. So goal of this, so what we end up with version 4 is Jenkins and a thin layer of Jenkins sitting on top of Travis CI, chef cookbooks, giving us a nice repeatable build environment that also lets us take our test to a hosted CI system if we need to. So if you are on a project and you're okay with being hosted in a public CI system, you can go run them in Travis CI, or you can take them onto EC2, or you can take them back behind your firewall, which is often a use case that we have here with larger corporate clients, is that they're very afraid of having their code out there on the inner tubes. We're sort of like, well, your code isn't particularly valuable. It's really what you do with it. But they're very afraid of sharing that code with any foreign hard drive they might not have gotten to expect physically. And so having an ability to spin up instances anywhere and have this shared runtime is really useful for us. So this slide is just a list of the things that are available in the Travis CI cookbook that are sort of one line away in your lobot.yaml file. If you want to add these to your build, if you find that you need Maven for something, I'm sorry, you can go and add Maven to your lobot YAML file, you rerun chef, and you now have Maven installed on the box. This actually came in handy about a week after we finished the first pass at this, when we got our first Python project in the office, which was a momentous event for many other reasons, because we've been a Ruby shop for many years. We've also done mobile. So we've been doing Android. We've been doing iOS. We did WebOS when it was a thing. Like we do other things, but Python was something we'd never done, or at least as a company. Plenty of people had done it. And so when that first project came in, we fired up a CI instance, added the Python. I'm not even sure what the PyPy is. I'm not sure what the Python package repository is. Added those recipes and rechefed the box, and they were completely happy with what they had and were able to get their build going that day. So it gives us a nice flexibility to go in any sort of direction. We're definitely looking at hosted CI, Circle CI. It seems awesome. There's also plenty of other, there's Circle CI, there's TDDM is out there as well these days, and there's Travis. So we're sort of excited about all of these opportunities for outsourcing all of this work, because even it's not a lot of work to run our own instances on EC2, but we'd rather not do it at all. And so we're looking forward to it, and this is sort of a way to bridge us into that mode of working. So I wanted to spend a little bit of time tonight going over, sorry, I don't know my slides as well as I should, so I'm just going to keep going. The lifespan of a CI build and a project at Pivotal. Question in the back?
I had a question, but it seems like related to the last slide, so I didn't want to skip it over.
Go ahead. Yes.
So why did you move to Travis after Jenkins?
We have not. So to clarify, we haven't moved all of our projects to Travis. What we've done is through Lobot, we can configure an instance that looks exactly like a Travis worker. And so for the vast majority of our projects, we spin up a box on EC2 that has all of the same things installed that Travis installs on their CI boxes. So they deal with the hard problem, like what versions of Ruby to install, how to install Ruby, how to install various libraries so that headless web browsers can work. We get all of that on our instance running with Jenkins, just so it's set up like a Travis worker, but it has Jenkins in front of it. So the project then, if the project wants to go to Travis, it's a fairly small move, because the boxes are going to look the same when they're on a hosted Travis instance, or when they're on an EC2 instance, or when they configure that in on their own box, in their own office, or in their own data center. The goal behind moving projects to hosted CIs simply to get out of the business of dealing with instances at all. If we can get to a point where we can comfortably flip a switch and say this is going to work for 90% of our projects, we'll be happy to do that. We'll probably be happy to do it when we're at 50%. We're trying it out now with various projects on I think all of the hosted CI providers. We've had projects on Circle CI, on TDM, and on hosted Travis. And so we're sort of still collecting information as to which one we like best. We're excited about all of it. Like I'm excited that it's going to be a thing that any project can have for a small, a checkbox and a credit card instead of even an hour-long process of setting it up. So however, I think there will still be a need for projects that have specialized dependencies to still have their own build instances at times. So if your project is, a bizarre project that has hard or necessary daemons that take hours to take a long time to install, something like our Android projects actually have to download all of the Android SDK, which is, I think, it's between 1 and 2 gigabytes to actually be able to run the Android tests. So something like that currently doesn't work under Travis. It may work in some of the hosted CI providers now, but these things that take a long time to install don't tend to work if you can't customize the CI environment. So there still will be a need for that. We also have projects that, for like operations-heavy projects where we're writing chef recipes or other automated configuration that spins up an instance and actually configures that instance and installs all of the application servers, installs all of the backend. If we're automating all of that, we want that in CI too. That usually needs to have credentials to actually go out and talk to EC2, talk to some other actual systems in the world. So for those cases, we usually run it ourselves. So it's nice to have the ability to go back and forth. So when you start out with a brand new project, you set up CI and you've got like 2 tests. And like you break a test and 2 seconds after you push, CI goes red and you're like, this is awesome. Like if the developer over there breaks the test, it goes red and it's amazing. You didn't have it the first time and you're like, okay, this is perfect. And then about 3 months in, CI is starting to get a little slower. If you're actually writing tests, I don't know, it varies based on projects, how disciplined you are about writing fast tests, how many tests you're writing. But I tend to expect a project that's been going for 3 months of real test-driven development to have a build that's 10 to 20, maybe, well, probably 10 to 20 minutes. This isn't giving you quite the feedback you expect, and you may have 1 or 2 somewhat intermittent failing tests. And after about 6 months to a year of actually writing tests, you get to this point where you don't want to talk about CI anymore. I haven't seen a large project that didn't get to this point, unfortunately. I think there may be some out there, you may have worked on them, but all of the projects that I've been on where they've really been writing tests for a year, they get unhappy with the process of pushing a build up there, waiting 30 minutes, 40 minutes, don't know what it is exactly, and then getting some random failure that doesn't look like anything they touched. It just happens to have failed that time, unlucky them. So what they do is they log in and they click build now. And then the test goes green and they go home. And so what I want to talk about a little bit is how to avoid this problem. We heard about parallel tests in the last talk, and what I tell people is to start with parallel test. When you have 2 tests is the time to install parallel test. It will take your build from 1 second to 1 second. It won't help you at all. But what will happen is that when you have 5 minutes worth of tests, they will have been parallelized from the beginning. And so you'll have dealt with the hard problems of how to write parallel tests as you go through the process of designing your test suite. Retrofitting this after the fact is challenging. Doing it up front, it just becomes a fact of life. It's not actually that much harder. You really only have to think about it when you're adding some new sort of shared resource. But you won't do it up front if you don't have parallel test installed. One project I was on was an extremely Solr heavy project. So the tests were all designed, the tests actually had to test Solr because that was every request that came into the API went through Solr. Excuse me. But that Solar instance, there was one of them for the test. So every test had to be run serially. This ended up getting us an hour-long CI build. If we'd had parallel test installed, we would have figured out how to spin up multiple copies of Solar. We would have been able to run our tests in parallel and bring that down. On a modern, if you need to scale your CI build on one instance, I had one project that had an hour-long build on a Mac Mini that on a cluster compute instance on AWS was about 5 minutes. The cluster compute instance cost $1,200 a month, so they didn't actually end up using it, but they had the ability to sort of turn the dial to how much they wanted to spend, how fast they wanted their tests to come back, and so it's a nice option to have. It's a lot easier to start up front when your project's small than retrofit it later. And this is perhaps a more controversial statement than starting with parallel tests, which is to stop writing Selenium tests. I've been on plenty of projects that have had large quantities of Selenium tests, and all of them are more flaky than tests that are not involving Selenium. There's certainly a skill to writing Selenium tests that don't fail intermittently. If you've done it for a while, you can sort of predict when things aren't going to work in the long run, when the browser slows down, what your race conditions are going to be. So you can get better at this. You can make Selenium tests pass, and what I tell people is that you'll know when you need them. If you sort of sit down in the morning and your first thought is, well, I have this story that I'm going to implement, I'm going to write a Selenium test, I tend to think you're going to end up with a test suite that's fairly unmaintainable in the long run. If you sit down and say, we're doing this large feature over the course of this week, we really need to know that the key parts of it work. We need to know that a customer can actually place an order on the website. That is a great time to stop and write a Selenium test that actually fully tests your application end to end. But don't write them for each little feature you add. Don't write them for when they click accept and when they click decline. You should be able to write a much smaller focused test either at the JavaScript layer or at the controller layer that demonstrates what those behaviors are going to be. Here at Pivotal, we've written Jasmine, a JavaScript testing framework, which has eliminated a lot of the need for these sort of, well, it's in the browser, I couldn't possibly write a test for it other than a Selenium test. Yes, you can. Set up Jasmine. There's a Jasmine gem that makes actually testing that JavaScript much easier. But don't be afraid to, when you know that you need a Selenium test, write that 1 or 2 Selenium tests. But stop writing them every day. Fix the broken tests, not the broken build. I've seen many, many projects that log into CI, click build now, and hope it goes green. I tell people to stop doing this. If you see a broken test, if you see a test run that doesn't seem like it should have failed, it doesn't seem related to anything, everybody kind of knows when they have a test that's failing in CI that isn't something that's breaking, it's just a race condition of some sort. What you have to do at that point is have somebody stop and actually look at the test that failed and think long and hard about why it might have failed. Race conditions are some of the hardest things to trace down. They're the hardest things to think about. And as Ruby programmers, we're not very good at it. Most Ruby programmers don't deal with threading issues on a daily basis. And so when you get to a broken Selenium, or at least an intermittent failing Selenium test, you have threading issues, even if you don't know it. JavaScript is asynchronous. Things come back at different times. You have to start thinking about what happens if this happens before, what happens if it happens after. It's a mind shift to get into that mindset, and nobody actually wants to do it. They want to keep going with the cool thing they're working on right now. But taking a moment every time you actually run into a broken test and making it reliable. So do something that you honestly think will make the test not fail again. If you don't think you can actually fix the race condition that's making this test fail intermittently, delete the test. It's far more valuable to have a CI build that's green and red when your tests are green and red than to have an intermittently failing CI build that happens to test this one feature that occasionally might go red. I'd much rather get that information about all of the tests that I have are green than, well, we still can't figure out how to test that thing quite right. So we leave that test in there so that it reminds us that we should go do something about it. It's not particularly valuable. You can mark it as pending if you want, but don't leave intermittently failing tests in the build. One project, actually the tracker project, which I'm allowed to talk about as opposed to some of our clients, has a tracker's been going on for, gosh, I'm going to guess 5 years now. I don't actually know the number. And it's always been a JavaScript heavy app. They have a lot of Selenium tests. And so what they ended up doing was assigning a pair to be the build pair. It's not a build boy. They're not the person who goes and sets up CI and who makes sure that the jars pop out perfectly at the end. They're the pair that when the build goes red, their job is to look at it, see if it's related to something that just got pushed, let those people know let the people they think might have broken it know that they broke the build, or if it's an intermittent test, to stop what they're doing and actually fix the test. So it's a hat that's assigned to a given pair every day, or at least was for a while they were dealing with intermittent failing test issues. They reported that it really helped them get their test suite to be much more reliable. And I think it's really useful to, if your team has lost that, the build is red, what am I going to go do? It's a great way to sort of appoint somebody, not one person every day, but someone every day on a rotating basis to actually be the person who's taking responsibility for this. I tend to be contrarian from the master is always green approach. I don't mind people merging red code to master as long as someone is actually fixing that red build when it goes red. I think if you start gating pushes to master, you end up having more things in your head than you want to be thinking about, as long as you're not pushing broken builds on a regular basis. This is sort of a Jenkins-specific tip, but in Jenkins, you can, on a given build, there's a notes field. You can go in there, and what I tell a team to do is every time you have a broken build, go in there and write, and if you're the person who's actually read through the build log, figured out why it failed, go in there and write the reason why it failed. You can say, this new code was pushed for blah, blah, blah feature, broke the build. We're not trying to assign blame. We're trying to figure out why the build failed so that somebody else sees a red build, doesn't have to actually go and look at it. And what you also want to do is, if it's an intermittently failing test, note which intermittently failing test it was, what class of test, and which actual test it was. After you do this for a week or two, if you're having a couple of broken builds a day, you'll be able to log into Jenkins and have this long list of exactly what your problems are with your test suite. A lot of projects I log into, and they have a red, blue, green balls on the side, but you don't really know why they're red. You don't know what's causing this. Was it that the build has continuous deployment at the end, and the deployment failed? Was it? We don't know. If when you look at these builds, you start annotating them, you save everybody on the team from having to do it, and it allows you to sort of get this overview really quickly. And unfortunately, sometimes you may be doing all that, and your builds may still suck. I'm sorry. You're still going to have to put more time in, and you're going to have to sort of get into the advanced CI topics. These are sort of harder things that you can do when you have a larger build. For good reason. You're probably on a project that's been around a long time. It's probably proved that it's valuable to somebody because you're still investing in it. Maybe you just wrote a lot of slow Selenium tests up front. We don't know why you got here, but we don't assign blame. We're just trying to figure out how to keep developers being productive. So the quickest, easiest thing you can do is go get faster instances. If you can go and buy a fast box, put it on there. If you have a parallelized test suite, it's going to get a lot faster. You can investigate build pipelines. So I don't know of any of the hosted CI solutions doing build pipelines, but with Jenkins, there are various plugins for when I push code to, when I push code to Jenkins, do these two things in parallel, and do this third step at the end if the last two things are green. This can allow you to split out your Jasmine tests from your unit tests from your Selenium tests and get even more parallelism. You can then split that out into multiple worker boxes so that they're running at the same time as fast as you can possibly make that. There's quite a bit of overhead to setting that up, but it can be necessary on larger projects. And the last thing on this list is the one I hate the most, but is sometimes necessary, which is dividing your build up into fast and slow suites. There's a time when you have an hour-long CI build where it's not providing you the value that you wanted when you started writing all of these tests. If you have some tests that are extremely slow, but you have a vast majority of your tests that are fast and are providing you useful feedback, spin up 2 CI jobs, have one of them run what I call the good tests, and have one of them run the bad tests. What will quickly happen is that the bad tests will be ignored. Unfortunately, I tend to find that you've split those off for a reason. They're slow. They usually have some sort of intermittent failing issues, and oftentimes teams will start ignoring those. However, we now have a set of fast tests that tell us most of what we needed to know and allow us to move quickly. And so you can start adding test coverage in a reasonable manner to the fast suite and have sort of reasonable coverage. So that's all I have prepared. Thank everybody for listening. If anybody has questions for me, I'm happy to take questions. And I'm happy to talk afterwards. I'll be here for a while to talk about anything. So, yes?
I saw you mention different times CFD and Selenium, also Capybara WebKit.
Yes.
Yes. Different projects.
Yes, sorry. I should have explained what those all are. Yes. No, they're all tools. They're all tools that allow us to run Selenium tests on a headless instance. So an instance that doesn't have a video card in it. So XVFB is an X virtual frame buffer. So it actually gives you a X session that you can VNC into that doesn't exist anywhere, that doesn't exist on a video card. So that's sort of the thing you need first to start running any sort of Selenium tests. Capybara WebKit then is a web browser that's it's sort of this amalgamation of a web browser and Capybara in one. It still requires you have XVFB running, but it doesn't actually launch a graphical interface. So you can write Selenium tests against Capybara, and you can switch your driver to Capybara WebKit, and it'll be much faster because it's not actually drawing any of that on the screen. And you don't have to actually have a browser pop up in your face and watch your tests run. There are downsides to this because the headless browsers aren't quite as good as knowing when things are visible. Because they're not actually displaying it, they can't actually look at the pixels and see. So when you if you switch from a normal Selenium suite to Capybara WebKit, I generally expect to see tests run twice as fast, but I expect to have a couple failures related, or a couple to maybe more, depending on the size of the suite, failures related to the API not being quite the same thing that you expect for visibility and interaction with things. There also are things that Capybara WebKit won't do. So there are some limitations and differences in the API. There are other solutions in that space like Phantom.js, or Phantom, which is Phantom.js, which is JavaScript headless testing, which uses WebKit, sort of attacks it from the other side, but it's the same idea for running the JavaScript or Selenium tests in a browser without actually firing up Firefox or Chrome. So yes. Yes.
I remember somebody talking about something about learning how to write your tests in parallel, and I'm a novice programmer, and I've not built anything past trivial. But if I wanted to just like experiment and just goof around and learn, is that really something that you only do when you need it, or is that something that like somebody who's learning kind of from the get-go is there like a pattern to kind of be aware of so that as you're writing your tests you can keep that in mind?
Yeah. So Parallel Test is a gem on GitHub, published on Ruby Gems, written by Michael Grosser, which will actually take an RSpec suite. It'll divide it up by the number of cores that you have on your box, and it'll spin up 4 RSpec processes, or end processes and actually run all of your run those in for test suite. It'll also profile that. It'll profile the test run so it actually knows how long each individual file takes. And so the next time through, it'll actually have a better idea of how to split it up per processor and give you sort of an even runtime eventually after a few runs of each processor finishes at about the same time, give or take something. That's something you can go to the parallel test README, set that up. It doesn't take any special knowledge, and you'll pretty quickly, as soon as you write a test that has some dependency on something that is shared, you'll pretty quickly start seeing failures when you run your test suite. So it'll actually walk you through like how to create different databases so that if your Rails app is connected, if all 4 of your test processes are connecting to the same database, one will finish a test and it'll clear out the database while the other test is in the middle of going. So the first sort of issue you have there that it walks you through is, how do I create 4 databases in MySQL and point each one of those processes at the correct MySQL instance? So that's sort of the first issue you have to deal with. When you add something else to your build, like Solr or Memcache or something of the sort, you'll have to deal with the same issues. You'll sort of have to figure it out for that given component piece of infrastructure that you're adding to your application that you're actually writing tests around. Is how do I parallelize these tests as well? So it's something that anybody can start with. It's easy to get going. There are some challenges as you work with it, but it's generally not a huge cost to maintaining it if you start it from the beginning. Another question?
Actually, I was calling the last one. I had
Sure.
the last bit I wanted to ask, which was, is there a favor around Pivotal, or are people using the different browser type testing kits for different purposes, or what's
Sure.
are some loved or some
Sure.
hated?
So
I guess you
Sure. I've supposed to have been repeating the questions. I'm sorry for anyone watching the video. I haven't been repeating the questions. But the question is there a favorite around Pivotal for headless browser testing? I think I would say Capybara WebKit is our standard these days for headless browser testing. It's fairly easy to set up, and it does give you a speed up, and it's sort of made to work with Capybara nicely. Some projects have also used Phantom.js. Some very JavaScript-heavy projects have with success. So I just haven't been involved on those, so I don't know. And I would also say if you're writing Jasmine tests, Jasmine generally, I find that actually Jasmine is almost easier in a web browser than it is headless. So a lot of people feel like they need to get Jasmine specs running headlessly. It doesn't give you a whole lot of benefit to run them headlessly. The best interface for interacting with your Jasmine specs right now is probably the web browser. I would recommend use the Jasmine gem until that hurts. We have one project that is entire JavaScript. It's a JavaScript single-page app written in Backbone that's been going for, I guess, 2 years now. That has a really long Jasmine test suite. They have actually dealt with getting it running in various headless browsers and picked the one. I think they picked Phantom because it was faster. But for the most part, if you're getting started with Jasmine, don't worry about that. Worry about learning how to write testable JavaScript and just run it in a web browser. Jasmine comes with no, in CI, in XVFB. You will still need XVFB for any of the headless browsers. They still need the WebKit code, I believe, still expects there to be a frame buffer available. They just aren't drawing it on. They aren't actually going through the action of drawing it on the screen. So you can run Jasmine tests in a browser. Like the Jasmine gem actually comes with a really easy way to run Jasmine tests in CI. It comes with a rake Jasmine :CI task that actually fires up a web browser. It has an extremely ugly or beautiful hack, depending on how you look at it, to actually report those tests back through the command line through an RSpec formatter. And so the CI task will launch a browser, run the tests, report them back on the command line, and fail the build if they're red. So we certainly do run all of our Jasmine tests in CI. We just don't worry about testing them headlessly. Any other questions? All right. Thank everybody for coming. I hope you had a good time.